All right, so we want to look at the two types of collisions, elastic and inelastic. Of course, these are based on the law of conservation of momentum. The total linear momentum of a system does not change if there are no net external forces. What does that basically mean? As we said in class, momentum before a collision equals momentum after a collision. Please notice this says law, so this is always true. Momentum before a collision equals momentum after a collision. And our equations are based on that statement, the law of conservation of momentum. Since our conservation of momentum comes into play with collisions, one thing to maybe think about is who always quote-unquote wins in a collision. Now, a lot of things go into collisions and what happens and if somebody gets hurt or if something gets destroyed or not. But the best way to think about it is the object with the most momentum, quote unquote, wins the collision. So if you think about two football players, the one with the most momentum will usually knock down the guy that has less momentum. The car with more momentum will usually take less damage than the car that has the least amount of momentum. Okay, now there are, again, a lot of factors that go into winning, quote unquote, in a collision. I don't know what that means necessarily, but from a physics perspective, in a collision, you want to be the one with the most momentum. Okay, so our two types of collisions, elastic and inelastic, we talked about those in class. Collision in which objects bounce apart, kinetic energy is conserved. Inelastic, collision in which objects remain stuck together, kinetic energy is not conserved. So again, here's our two equations. We'll use those in some sample problems. Okay, so let's look at this problem. John and Sally are on skateboards at rest. John pushes Sally with 1,000 newtons of force. Sally leaves with a velocity of 5 meters per second, and she has a mass of 70 kilograms going to the left. John leaves at 7 meters per second to the right. What is his mass? So as I look at this problem, first thing I want to notice is that it says John and Sally are at rest. So, oh, come on, pen, work please. I notice they're going to fly apart here. So that tells me elastic. Or actually this one could be inelastic as well, it doesn't matter, because if we start at rest, I know the before side has 0 momentum. If you start at rest, you have 0 momentum. So I know the before anything happens, it's 0. That has to equal the after. So Sally has 70 kilograms with a velocity of 5 meters per second to the left. So I will make that negative, plus John, we don't know his mass, but we know he goes 7 meters per second to the right. 0 equals negative 350 plus mass times 7. So 350 equals 7 times the mass. Divide by 7, and we get 50 kilograms. So for this one, you want to realize since you're at rest, one side of the equation will be at 0. They're both at rest, so one side would be 0. And then you solve for mass. Okay, let's look at one of these examples. Now it does say inelastic. It will not say that on a quiz or test. You have to figure out. So two cars collide and lock bumpers. As soon as I see that, I know it's inelastic because they stick together. 1,000 kilograms at 20 meters per second left, 800 kilograms at 15 meters per second to the right. What is the velocity of the cars immediately after collisions? So our inelastic equation, m1v1 plus m2v2 equals m1 plus m2, because they stick together, final velocity. So we have 1,000 kilograms times 20 negative 20 meters per second is to the left, plus 800 times 15, we're going to keep that positive, it's to the right, equals 1,000 plus 800 VF. Okay, so now we want to do some math. 1,000 times a negative 20, negative 20,000 plus 800 times 15, 12,000 equals 1,800 VF. So now we have negative 8,000 equals 1,800 VF. And of course, I'm running out of room here. VF, we're going to divide negative 8,000 divided by 1,800. And I get 4.44 meters per second. I'm sorry, negative 4.44. Help if I could read my calculator. So that tells me it's going to bounce to the left. Bounce to the left as these two guys collide and stick together. And that makes sense because the object to the left has the most momentum that will win the collision. So let's look at this sample problem. Again, it tells you elastic. It will not tell you that on the quiz or test. So we have 5 kilograms with a velocity of 24 meters per second plus 1 kilogram times negative 40. Now we have to remember a baseball bat will swing one direction, the baseball will be coming from the opposite direction, so that's why I made it negative, equals 5 all right, so 5 times 10 meters per second plus 1 kilogram times velocity, which we don't know. So 5 times 24, 120, plus 1 times negative 40 is negative 40, 50 plus V2, which is what we're solving for. So now we have 80 equals 50 plus V2. I will subtract 50 from both sides and get 30. Remember, we're going to subtract. And that will be our velocity, 30 meters per second. All right, so let's practice some of these and let me know if you have any questions.